So hello everyone, I'm Pritham and today's Leetcode question is a medium one, but it seems to be like hard one. It is like the same question that we solved yesterday, that is fruits into baskets third. Previous one was second, it is third, and the problem number is 3479. So what we have given, I have to read it again as we have done in like last day. So you are given two arrays, fruits and baskets, each of length n, and where fruits of I represents the quantity of the ith type of fruit and baskets of j represents the capacity of the jth basket. So you have to, like as we discussed the yesterday, like from left to right you have to put or place every fruits to the baskets, and you have to count that how many fruits are unplaced. So that is all about here, and the constraints given here is the each basket can hold only one type of fruit, so you have to consider only one type of fruit to be placed into the basket, one basket. And here why it is a medium or hard question, because the previous one is having n is less than equals to 10 to the power 2 or 100, but here we have given it is as 10 to the power 5. So we have to solve this one. So let's go to the logic part first, then I will be code it. It is already solved by me previously, but let's see how it will be going. So today's question is also the follow-up question of the previous one, and the question is like you have given two arrays. First one is fruits and the second one is baskets. So you have to just place all of the fruits into the basket, and you have to count how many. So you have to count how many unplaced fruits will be remain after placing all the fruits into the basket. So the previous one have n up to is 100, so it could run into n square, n cube, and n to the power 4 complexity. We have discussed that problem into the previous one with the n square complexity, and here we have given n up to 10 to the power 5, so we can't run like any of these solutions in this question. We have same question, but the complexity and constraint are different. So for this question, what we will be going to do is just we will use a segment tree plus binary search. And how I will be doing this? So you just have to build a segment tree with the maximum capacity of the basket. Like segment tree is nothing but your binary tree, so it will be like this. So if you have basket array as like this, like 2 3 4 5, then 2 will be here, 3 will be here, 4 will be here, 5 here, and maximum of both will be here, that is 3, maximum of both will be here, that is 5, maximum of both will be here, 5. So this is your segment tree that we have to build. And then what we'll do, we'll just check that in this range, like we have 0 1 2 3, so we have 0 to 3 range. So in this range we'll check that which basket capacity is like the one which can be used to place a fruit. So for that, what we'll do, we'll just check if we have a range of 0 to 3 basket, then in the middle we'll go and just check from like it will be 1 to 0. So in this range and in this range, this will be two parts. We are using binary search, so we have a two parts. Then in this part we'll just check that if there is someone, like if there is some basket that can be used to place any fruit of I. So for every fruit will check that in this range, like is there any basket that can be placed, and for that range, like in this range, what is the maximum basket capacity is there. So for that we are using segment tree, like in this range, which is the basket one, which is having the maximum, and we build the segment tree in this manner that the maximum capacity bucket will be at the top, and as we move like in the deeper side, we'll get that if these two having like buckets, then the maximum one is here, and both of them here, then the maximum one is here, and max of both is here. So if I have to check that in the range 0 to 1, here if we consider this is 0 to 0 range, this is 1 to 1 range, this is 2 to 2 range, 3 to 3 range, and if you consider this one, this will be 0 to 1 range, and this will be 2 to 3 range, and this will be 0 to 3 range. So we got the total range of the baskets 0 to 3, that is here, and we have to check that into 0 to 1, which is the maximum one. So we'll go from top to bottom and check for the range. That is your like uh, in segment tree we have three function. One is build, another one is query, and another one is update. So here we first build the segment tree, and we have a query like 0 to 1, which is the maximum capacity basket. So for that we'll just run a query of 0 to 1, then we'll get maximum capacity as 3, and if we get maximum query, then what we'll do, we'll just for the mid, we'll consider mid bucket as our like target bucket basket in which we will place the fruit. But if we got that this is the maximum one and it is greater than the capacity we needed to place any fruit, then we'll again move into the sub tree of that if we have 3 and we needed like 2 capacity, then why we'll choose this one, we just check like if in the left is there anyone like which is having 2, and in that we'll just store that fruit. So if we get like it is lesser than, then we'll just stop, and then we'll check the right one. If there is a right one, again that capacity is greater, then again we'll move into that right subtree, and when we'll just check into the right subtree, and again like in recursive we will just check out, and whenever we find the right basket to place, then that will be used to place that bucket, and that is our the logic here. So we have to build first the segment tree, we have to query for the range that which this range, like in this range using the binary search. In the binary search we'll just go for this part and again part, like whenever we are getting the right basket to be placed there, then we'll just place that basket, and if it found that it can't be placed anywhere, then we'll just count that uh, fruit as unplaced, and that will be our answer. So let's go to the code part. I have discussed to you the logic where I didn't mention that how much complexity it will take by using segment tree with the binary search. So for like building you the segment tree, it will cost you n log n, a space and time complexity as well, because you have n nodes, and in the hierarchy, like the parents and then those parents and then those parents, it will cost you n into log n complexity. And that will be for building the segment tree, and for the binary search you will have log n complexity. So it will be n into log n into log n. So that is what it will be. So let me code it out. Let's go. No, I just told you the wrong thing. I just Okay, so we don't have to binary search and build again and again. We don't have to build again and again. We just have to build a once for, like, the segment tree will be built only one time, so that will cost you n log n, and log n for the binary search. And for each binary search you have to traverse and check for the maximum capacity bucket that is suitable for your fruit. That will cost you maximum up to 2 into log n time complexity. So that is like also your log n into log n. And I think n into log n is more than the n log n into log n. So maximum worst time complexity will be n log n. So that is all about the time complexity. And let me code it out for the segment tree. So let's start for the segment tree. So for that I have to initialize segment tree, let's say, and it will be a size of like, as I have mentioned, that you will be having children's like n nodes, and then the parents and their parents and their parents, that will be of n into log n, a space complexity. So that is like we have given n as maximum 10 to power 5, and log n of 10 to the power 5 will be 5, that is of 5 into 10 to the power 5, that is of 50,000. So let me consider it as 50,001 for the worst case. And then we have to just build. Building we have to it's just for building we have what we have to do. We just have to index for the binary tree, because the segment tree is based upon the binary tree. So each and every node will have index, and that is used to find out the parents and children relationship. And another thing that we have to build here is that what will be the start and the end, of your range. Like you have to build in basket segment tree. So like what will be the this range and this range, like that. And we just have to here initialize a vector of basket, not initialize, it will be like building, we are building that. So here we'll just build here. So building, what we have to here send index will be starting from 1, and start and end will be from 0 to n minus 1, and that is your n m, let's say m equals to basket dot size. And then what you have to do is just send build total of this, and then baskets. Yeah, that is for the build part, and it will build you the baskets segment tree. And for that, what we'll be doing here, we'll just check if start equals to end, then just return. Okay, so we have to build. Okay, so building will be here, segment tree of index will be equals to that basket index, basket end or a start. You can use both end or a start. And that is all about it. and it will return. And if it is not, then just go move for the left subchild, that is your index, into 2, and it, like, you have to just find out the mid as well, that is your start plus end by 2. And here you have to go from start to mid, and just what we have to send as well, the baskets. And again you have to move for the right subchild, that is your 2 into index plus 1, and it will be mid plus 1 to end, and here as well you have to send the baskets. That is all about. Okay, and whenever you are moving from like left and right and left right left right left right, and at the leaf child, what you have to do is just maintain this tree, like segment tree values, and that will be your index wise, and it will be, we are just storing the maximum of the children, so it will be like segment tree of like index into 2 comma segment tree index into 2 plus 1. That is all about your building. So segment tree is built here, and you have to perform query. For query as well, you have to write it here. So query, you have to just check that this range is of this or not. Like, let me consider what will be here. First thing will be the start and end of the segment tree or the basket segment tree, and the query will be left and the right, that we have to check. And other thing is your index. So index, let me consider here is well, and that will be here, and I think it will be good to go. So you have to just check that start, you have to check that start, like your start, like first you have to check left one, if left is greater than your end, or your right is lesser than the start, then just return 0 not int minimum. Okay, and what we'll be doing again, that we have to check that in range. If you have done segment read, then you have to check that your query range into that segmentary range or not. If segmentary range is minimum to the query range, then you just have to return that segmentary value. So for that we have to just check if like, what will be that, like left is like greater and equals to the start, or like hmm, and right is your lesser than and equals to your end, then you just have to return the segmentary indices. That will be your maximum value at this range. And that is all about the query. And for moving into that, you have to find always the start plus end by 2, that is your mid. Yeah, that is your mid. And for querying inside the left one and the right one, you have to just do one thing, query, and indices will be indices into 2, that is your left subtree, and start and mid and left and right. and query into the right subtree, that is your indices, into 2 plus 1, and that is will be your mid plus 1 to end, and left and right, that is your query into the right subtree. And here as well you have to just return the max of your subtree, not subtree, that is segment tree of your left subtree, that is your indices, into 2 and comma, that is your segment tree of 2 into indices plus 1, and that's all about your query. We have built the segment tree, we have queried the segment tree, and let's go for the last one out of 3, that is your update. So I think update will be not used here, because we just have to find out, yeah, we don't have to use update, so we have to just build and check out if is there any maximum or not. So we just have done the build and the query part, and we left with the main function that we have to do. So in this main function, just go for all the basket like 0 to m, and here what we'll do is just we'll have a left, that is your 0, and the right, that is your m minus 1, and your, is there anything that we have to go for? I think not. And another thing we have to initialize here is that it is your result, that will be initialized with -1, that it, because we have to like check which is the maximum one, so initializing with -1 will be good. And other thing, that is the main thing, that is count, you can slice with a count or n, so that is your 0. And here we have to perform the binary search, that is your simple thing, just go and if query of, we have to check for the range now. So query, what are the arguments, parameters we have to pass? So indices will start from the 1 goes to start to end. So start will be your left, right, no, we have to start with 0 to m minus 1, and we have to check for the left to right. So we have a 1 2 3 4 5, 1 2 3 4 5. Good. If that will return you that it is max greater than equals to the fruits capacity fruits. So we have to check for the fruits, like if these fruits can be placed here, then if that fruit can be placed here, then what we'll do, then we have to place that thing. I think we have to update, like we have result, so result will be your mid, like going from this subtree to this subtree, and whenever we are getting it is greater than equals to that, then mid will be your result. And whenever we got that is not, like if it is lesser capacity that we cannot place that fruit there, then left will be mid plus 1, and that is all about. So for updating part we don't consider, we have to update as well, because after using that So after like using that basket to place any fruit, we have to update as well. Like if after performing all those things, if we remain with like result is not equals to -1, that means we are using something, and basket result is greater than equals to your fruits I. That means we have to update, and for update we have to create a update function as well. So for that, let me do that quickly. Like just we have to update. For updating as well, we have to go beyond and beyond. And if we found out that, what is that? So for updating, what we have to consider is that we will be having the value to update with, and the value will be we will update with the int max. So let's go. So updating indices will start with 1, the same thing that is here. Let me copy and paste. So indices will be from 1, start will be same and same, and update with the value, another thing will be a value. So here we'll go with checking that a start is equals to int or not, and then we'll just, if it is that, then segment tree will be updated for the indices with the value, and will just return, and the remaining things will be same, my friend, almost same. We just have to find the mid, go for the update into the right one, and again we have to update here, and that is your segment tree of indices equals to that. That is all about this update. One thing I am missing is that we have to update that. For that we will be having another thing. Here we don't need left and right. We need a position where we have to update. So for that it will be a position where we have to, let's say indices where I have to perform that, and if that indices is lesser than and equals to like mid, then we will go for this, like start to mid, else we'll go for this. That is all about this. Yeah, that is all about update part, and I think that is all about this. So we have to send the start and end, that is your 0 and my m-1, and you have to send the indices where you have to perform that, and that is your I, and your value will be int min. So you have performed that, and if you don't update, that means you have not placed the fruit, then you have to count plus plus, and that will be your answer. And that is all about this. Just return the count. So let me check it out. We have done lots of codes, so I have to check it out again, like if it is in, if there is any error or not. So let me check. And so after checking all the errors, like we have to return here the max of query 1 and query 2, and we don't have to update here. And other error I was getting is that some compilation error that somewhere I just use segment tree instead of segment tree, and that's all about that. And after all of this, it is okay. And I hope you understand the logic behind this question. And the code is like very lengthy, but you can understand. And so that is all about this question. Let me submit this question. It will be right. I have like checked all the errors, and somewhere it is giving like, okay, that is not happening. So now it will be okay. So that's all about this problem, and thank you for watching this video.